In this video, we're going to look at vector analysis questions. To begin with, we have this question here, and the question reads, find the line that passes through the point -1, 3, 4, and has direction orthogonal to the direction vectors of both. So we have these two lines that are given here in the question. So they're telling us to find the line that passes through the point, this point here, which has been given, and has direction. So the direction of this line that passes through that point is orthogonal to the direction vectors of these lines that are given here. So that means that we must find that orthogonal vector, and we must find that vector which is orthogonal, and that vector which is orthogonal in this case will be the normal vector. So now, before we do that, we must first find the direction of these lines. So we have line 1, which is given by, I have x equal to 3 minus 2t, y equal to 4 plus 3t. Then I have z equal to 7 plus 5t. Then the other one is line 2 is x is equal to -2 plus 4s. Then y equal to 3 minus 2s. Then z equal to 3 plus s. So in general, when we describe a line, or this line is formed by the vector saying rt, where I have x naught being any point, then I have t, I have a, and then t, then a here, which is being, this a here is the direction of this vector. So it's the direction of this vector. Then I'll have y as well as y naught. We have a point there. Then I have b also, the direction of what, of t, z naught plus c t naught, like this. So this here is the general form of how we find this. Now, for this question, because they've told us that it has direction vector orthogonal to the direction vector of both these lines, so we must find that vector. So to find that vector, we have to find the cross product of the direction vectors of these lines. So we first get the direction vectors of these lines. So I'll say D1 is going to represent the direction vector of this direction vector of these lines here. So this number here that is just before t, these here are what are the components of the direction vector. So I have -2 there, I have 3, and I have 5. So this is the direction vector of the first line. Then for the second line, the 2, I have that the direction vector is, so here where there's 4, 2 there, and 1 here where there's s there. So I have 4, I have -2, and I have 1. These here are the direction vectors. So direction vector for the first line is this one, D1, D2 for the second line. The next, now here, what we must do to find because they've told us that it's orthogonal, meaning we must find the cross product of this, which is going to be D1 like this, then cross with D2. And this here will just be equal to, so this is going to be equal to, have I, j, and k, these here being my unit vectors. Then I put in D1 first of all, which is going to be -2, 3, 5. Then the other one is 4, negative 2, 1, like this. So I must then find the cross product of this. So to find the cross product there, what I do is I'm going to say erase this top part. So to find that, I'm going to say I have I here. So when I choose my I, where I is, I'm trying to find the determinant. So I'll cancel out this here, this line and that one, and remain with this here, this matrix that is there. So I'll write it as 3, negative 2, 5, and 1. Then I say minus. Then J, I'll do the same. Where J is, I will cut off this and just get these values that remain here and form a matrix. So that will be negative 2, 4, 5, and 1. Then plus, so the sign alternates positive, negative, positive, just like that. So then I'll start K, then cancel out this one and that one, then remain with these numbers here to form the other matrix. So here I have negative 2, 4, I have 3, negative 2, like that. So this is how my vector is going to be. So now I must calculate what I have here. So here we have I, then we must multiply here in the major diagonal, that is 3, then we multiply in the minor, then we subtract. So that is 3. When multiply negative 2 by 5, we get negative 10. Then we're saying minus this 3. So that negative sign changes to be a positive sign, and that will be 10. Then I have minus that negative sign. So I multiply here, negative 2 and 1, and I just get negative 2. Then I multiply the 4 and the 5, that will be 20. So minus this negative 2, that will be minus 20 here. Then I have J like that. Then I'll have here to be plus. Then negative 2 by negative 2, that gives me positive 4. Then here I have 3 by uh, I have 4 by 3, which is 12. So minus 12 here, and then K. So this then gives me this then gives me 13. This gives 13I. And then here I'll have a positive 22 J. Then the other one is going to be negative 8 K. So here this is my vector, which is what? Which is orthogonal there. Then they have already given me a point, which is, so we say this point P naught, we just call it. Then the point is negative 1, 3, and 4, like that, which represents X naught here, Y naught, and then Z naught, like that. So to write this, to find this line, proceed then my N, which is just this vector which I found, my N, which is representing the direction now, which is just that vector found, is 13. This will be 13, like this, comma 22, comma negative 8. So I'll have this here. So this is my A, B, and my C. Then from here, I'm going to say, okay, we're going to say that R of t function like this is going to be, so you get your X naught. So I have my X naught, which is negative 1. Then you're adding plus this A here value multiplied by t. So that would be 13t, like that. Then I get the other y, then my b there is 22, then multiplied by t. Then I have the other one, 4 minus 8 multiplied by what? By t. So I'll have it like this. Then this means that my line, so this here is the vector This is the vector equation which I've written down. Now to write down, because they're saying we should find the line that passes through. So we must describe this line by its parametric equation, and that is just going to be written as, so say this line is going to be, uh, this line is going to be, so you have the first one here which represents x value. So x, that would be that, plus 13t. Then you have the one that follows y, that is 13 plus 22t. Then you have z to be 4 minus 8t. So this is how we represent and this is how we write and find that line. Okay, we move on to the next question. So in the next question, we're being asked to sketch and compute the volume of the uh, parallelepiped spanned by these vectors here. So it's spanned by these three vectors here. Then they're telling us what to sketch and compute. So to sketch, here we are going to sketch like this. We are going to have we will have three axes. So we will have the x, we have the y, and we have the z axis. So I'll draw my axis to be like that. Then I'll have another one like that. Then I'll have another like that. So I'll have my x, my y, and my z. So I can label these to say, can label this here being my, this one will be my, this is my x, my y, and my z axis is going to be here. So this is what I'm going to have like this. So now to plot, I'll start with u. So u is telling me that I have the first coordinate. So these coordinates are given as x, comma, y, comma, z. So for the first coordinate, they're telling me that in the x-axis, I just move, that's 1 unit. So let's say x1 is here. Then in the y, they're saying it's what? It's 3. So let's say x3 is what? Is there. So where these two, so I'll draw a line that is going to pass through the point x3 like that, and it will be parallel to the x-axis. Then I'll draw the line passing through 1 parallel to the y-axis. Then that is like that. I'll dot it like that. So this point here of intersection, this is the 1, 3, but then there's a move in the y, in the z-axis 1 unit up. So if I was to move 1 unit up, let's say 1 ends here. So this here is going to be the final point, which is my u vector being 1, 3, 1. So from here, I'll draw my vector. So I draw my vector from the origin to that point, which is going to be here. So that is my vector. Then I do the same for the next one. I have v. So my v shows 1, and my 1 is here. I said my 1 is there. So 1 is there. Then it is not moving. It has 0 here in the y-axis, so it won't move at 0. Then they're saying 4 units in the what? Uh in the z-axis. So I'll move up 4 units. So let's say that is 4 units there. Then I'll connect that point from my midpoint to the from my midpoint to the from my midpoint to that vector there. So that is going to be my vector v like that. Then that is 1, 0, 4. So that is my vector. Then I plot the other vector, which is telling me the other vector is -4. So if this here is my y-axis and this is the positive y-axis, then going this other way here, like this side, this is going to be my negative y-axis. So I move 4 units here. So when I move 4 units, let's say 4 is there, then they're telling me 2 units in the what? In the y-axis. So the y-axis is this one here. So let's say our 2 is going to be there. So 2 is there, then we're saying our 4 is there. So these here, they find the intersecting point, which is just going to be there. So now from there, I have to move, I have to move 3 units. I have to move, I have to move 6 units. I have to move 6 units, 6 units in the Z axis. So from there, I'll move up 6 units. So say my 6 units ends from there. So I'll connect that from the middle here up to where that vector is, like that, because that's a position vector. So I'll get it like that. Then that there is my W, which is negative 4, 2, comma 6, like this. So these are my what vectors. Then I can draw this shape by just drawing parallel lines to each vector. So I'll start with this long one, the longer vector here, and I'll draw a parallel line starting from this vector here. So I'll draw a parallel line like that. So it will be like that. Yeah, okay, like that there. Then I'll draw another parallel line for this vector here, the vector v, and I'll start it from the top here. It will go to that there, and I'll connect. Then I'll draw another parallel vector to the vector w from this vector here, and that will be like that. Then I'll draw a vector parallel from this to there of the vector u. Then this vector I've just drawn again, I'll draw another one parallel like that. Then this other one parallel to this one like that. Then I have that inside here. I have that small vector, can draw like that. Then I can connect from there to there. Then I draw another line from this side connecting to that there, which is parallel to this vector W. And that is going to be like that. So this is a rough sketch of how the parallelogram what will look. So now we are told to also calculate the volume. So to find the volume is given by the formula where I have W, then I'm saying, okay, I'm going to use W, I'm use V in this case, is V, then dot product of, I have U, the vector U, then vector U cross product with what? With V. So here I have first the vector U and W. You need to find the cross product. Then you do the what? The dot product with the vector V. And of course, this is in the what? In the modulus, meaning it always has to be positive. So I have to first find the cross product of U cross W. So you can do this with any of the vectors. You can first find the cross product of V with W. You can find V with W. Then you find the dot product with U, or you can do U with V, cross U with V, then the dot product or what W like that. It will still give you the same answer. So we proceed here and we say this is going to be, put in there your component vectors ij and k. Then I'll put in my U. So my U is 1, 3, 1. Then my W is -4, 2, and 6, like this. And this is just going to be equal to, I have I, then here I remain with 3, 2, 1, and 6. Then -j there. Then I'll have 1, -4, 1, and 6, like that. Then I'll have k there to be 1, -4, 3, and 2. So this is what I'm going to get. Then here I'll evaluate. So multiply, I have to find the determinant of this one. So that is just going to be 18 minus 2i. Then I have negative 6 plus 4 plus 4j. Then plus 2 plus 14k. So here this is just going to give me 16i minus 10j, then plus 14k. So this here is the cross product of u and w, and I can write this as so this can be written. So I'm going to write my first component, which is 16 negative 10, then I have 14 like that, and this is my vector there. So now from here I will replace there the equation or in the formula which we have this vector that I've just found. Replace that there in the equation. So my volume, I said my volume is going to be equal to that. Then go my vector v. So I replace my vector v. So my v is 1, 0, 4. Then the dot product of, so I replace the cross product which I just found, which is 16. Then 16, negative 10, negative 10, 14, like that, and modulus. So here, get the dot product, then that will be 1 multiplied by 16 plus 0 multiplied by negative 10 plus 4 multiplied by 14. And this here just gives me 16 plus 0 plus this will be 56. Then when I add this, I just get 72. And of course, the modulus of 72 is just 72. So I get 72 units cubed. So this is how I find the volume for this question. So next question is, this says write down the symmetric equation of the line joining A and what and B. So I have A, which has been given as 3, I have 4, 4, negative 3, 7, and B equal to 2, 3, negative 1, like this. So now from here, I've been told to find the equation, the symmetric equation of the line that joins these 2 points. So I must first find the direction here. So my direction AB is going to be gotten by going to subtract B from what? From A, like this. So that will be 2, 3, negative 1 minus my B is 4, negative 3, 7, like this. And I'll just get that, so I'll get 2 minus 4, that gives me negative 2. Then 3 minus negative 3. So the negative multiplies with that negative, becomes positive, and this will become 6. Negative minus 7, then that gives me negative 8. So this here is my direction vector. So I have my direction vector there. Then I choose any point, any of the 2 points that is joining between this point A and the point B. I can use any of the 2 points. So I'll use A in this case. I'm going to use A, and I'll say, so I'm going to say, I'll first find my vector equation. So my vector equation, right, okay, my vector equation, RT is going to be equal to, so I'm saying any point between A and what? So I'll use A for me, then I'll say plus T multiplied by my direction vector. So I'm going to now, so that is going to be equal to, I put my point, which is 4, negative 3, 7 there. then plus t, then my direction vector, which is -2, 6, and -8. So there, I then now replace, then now expand this out. So I'll have that. This is going to be, so I have 4 here, 4, then I'm saying 4, then we are adding here. So when we multiply, we're going to add component wise. So this part and that component. So that will be -2t like that, because I'm multiplying the t throughout. Then the next one is -3. Then I'll have plus 6t. Then the other one is 7. That will be -8t. So this is my vector equation. So from the vector equation, I can get my parametric equation. I can get my parametric equation. And this is just going to be gotten by saying this part here is the x component we're saying, and that one the y component, and that is the z. So just writing x equal to 4 minus 2t, then y equal to -3 plus 6t, then z equal to z equal to 7 minus 8t. So this here will be my parametric equation. Now, how do I get the symmetric equation? So to get the symmetric equation, you just make t the subject of the formula. So in each case, we're going to have that. So in the first part, when I make t the subject, it's going to imply that symmetric equation is going to be, so this is going to be t equal to x minus 4 over what? Over 2. Then I have t to be equal to y plus 3 over 6. Then I have t to be equal to z minus 7 over -8. So I have that there. And therefore, my symmetric equation, I'll write t. As I can see, there's t there, t there, t there. And I can just equate all this to 1t, and that will be x minus 4 over 2, which will be equal to y plus 3 over 6, should be equal to 7, z minus 7 over -8. So here, this is my symmetric equation. All right, we move on to the next and last question. And it says, find the, given that u is equal to this vector and v that vector, calculate the angle between the cross product of u and v, and then v and what? V and u. So the way we find that angle is by the formula cos theta to be equal to, so if we have two angles, let's say we have two vectors, a and vector b, finding the angle between here, then we are saying the modulus, which is the magnitude of vector A and the magnitude of vector B, like this. So, and here, this was saying the dot product of these two vectors. So now, let us use this formula to find. So we need to first find this vector here and that vector. So that is going to be, uh, equal to, I have u, so u cross v is going to be equal to, okay, that will be equal to I, j, and k. My u is 2, 5, and -7. Then I can write that v is just going to be, first coordinate is 2, one that follows is 1, and we see that there's no k, so meaning that is 0 there. So, meaning here when I replace, I'll have 2, 1, and 0, like this. Then I can find this vector, and I'll have I there. Then I'll have 5, 1, -7, 0, like that. Then I have negative j. Then I have 2, 2, -7, 0. Then I have k to be 2, 2, 5, and 1, like that. Then I find the determinants of these matrices that are there. And that is just going to give me, this will give me 7i, then I'll have negative 14j, and I also have negative k, like that. So this here is my vector, which is gotten by the cross product of u and what, and v. So I'll write it here, and I'll write it as 7, negative 14, then negative what, 8. Okay, let's find the cross product of the other one. So to find the cross product of that one, we're now finding cross product of v cross u, and that is going to be, so we do the same, we just replace, and we have I, j, and what, and k. Then I replace my u, my v is just 2, 1, and 0, and then my u is 2, 5, negative 7, like this, and that is going to be I. Then I have 1, 5, 0, and negative 7. Then negative j. There I'll get 2, 2, 0, and negative 7. Then have k to be 2, 2, 1, and 5, like that. And this is going to just give me the vectors. So the first one, I'll get negative 7i. Then I'll get 14 j plus 8k. So this is my vector, and this vector, write it here as v cross u is just going to be equal to negative 7, 14, and 8. So notice with me that the cross product of v cross u is just the negative of u cross v. So u cross v, like this is just equal to negative of v cross u. So when we found, in a case where you just find this first vector here, and you can multiply by the negative to get the other one, the other vector. So we now calculate the angle there, and the angle is going to be given as, I have cos theta to be the 2 vectors that I have, I'm finding. The angle between is this one, the product of this. Then we're saying dot product of that. Then the other one is v cross u dot product, like that. So then divided by the magnitude of u is v, and there also the magnitude of v was u, like that. And I'll have that. So replacing what I have on top, what I found, I have 7, negative 14, I have negative 8, then the dot product of negative 7, 14, and 8, like that. Then divided by the magnitude, which is going to be root, then I square each term. So I'll have 7 squared, then that will be plus negative 14 squared, then I'm going to have plus negative 8 squared. And again, for the other vector, I'll have negative 7 squared plus 14 squared. Then I'm saying plus 8 squared. Then I must now evaluate this. So this is going to be equal to, so this is going to just be equal to, so on top there, I'm going to have 7 multiplying by negative 7 plus, okay, just a moment, negative 14 multiplied by 14. Then I have, that would be negative 8 multiplied by what, 8. Then divided by, so when I square those terms and then add them, I'm just going to have root of 309, and also there root of 309. Then can add what I have on top. So on top, I'm just going to get 49. Then I'll have that will be negative 49, then minus 196, then minus 64. I multiply this throughout the root of 309, multiply by root of 309, I get 309. Then adding what I have on top there, I'm just going to get negative 309 over 309. And this gives me negative 1. So negative 1 there. So cos theta is equal to negative 1. And I can find my theta, saying cos inverse of negative 1. And this just gives me that theta will be equal to 180 degrees. So the angle in between those vectors is 180 degrees. Okay. If you are new to this channel, remember to subscribe and like for more this content.